today is I'm just going to talk a little bit about the test format, open up for some questions, and then just kind of get out of your way and let you guys start working on your half sheets or your views or whatever you want to get after today. So the test format, you should be able to solve problems where if I give you a rational function, you should be able to find its domain, vertical asymptotes, removal discontinuities, zeros, y-intercepts. I would probably do some of these as separate problems, like I'd give you a new function, just so that if you made some mistake factoring or whatever, doesn't like mess up like 10 answers. Okay. You should be able to give an example of a rational function that has a specific type of asymptote. So you remember those 3 rules for the horizontal and slant asymptotes. So if I say, write down a rational function that has the asymptote y equals 5, you should be able to give me an example of that. Or say something with a slant asymptote. You should be able to write down an example of that. So you probably want those rules on your card. You should be able to write the end behaviors using limit notation if I give you the graph of the function. So if I give you the picture, you should be able to write down what the end behaviors are using those limit notation. If I give you the attributes of a graph, you should be able to sketch the picture, kind of like what I had on the homework quiz, where I give you all the parts and you're just kind of putting them back together. I have 3 solving the rational equation problems. I have 1 solving rational inequality problem. That's like what we did last time in class. I have 1 multiplication division problem, kind of like what we did in one of the worksheets. And then 1 addition and subtraction problem, also like what we did on one of the worksheets. Any questions on the format, the question types here or anything? Okay. Do you guys have any like specific questions from the homework or whatever? Cheyenne? 39 from the problem set? Sure. So 2x cubed plus 5x squared minus x minus 6. So 2, 5, -1, -6 greater than 2, 5, -1, -6 greater than. Okay. So the first thing that we would do is set this equal to 0. Now to solve something like this, I'm going to default to the techniques from last chapter. Since this isn't quadratic, and it's not something that I see an easy way to factor by hand, I'm going to be using like my rational roots theorem and doing synthetic division and stuff to get my solutions out of this. So my possible rational solutions would be plus or minus the factors of 6 divided by the factors of 2. So the factors of 6 are 1, 2, 3, and 6. And then the factors of 6 divided by 2 are 1 over 2. 2 over 2 we already have. 3 over 2. And then 6 over 2 we already have. So those are our possible rational solutions. So let's go ahead and take a quick little gander at this function and see which one of these look like good starting points. Okay, so it looks like maybe -2 and +1. So let's just say I start with +1 because it looks like the most convenient one to use. So start my synthetic division. So that works. So I can take 2x squared plus 7x plus 6 and set that equal to 0. And to solve that, I'm just going to use the quadratic equation rather than factoring that, since the leading coefficient isn't 1. Prevert. Oh, hold on a second. This guy is not in this hour on a day. He's on my B day.
Oh, okay. All right. Thank you.
You're welcome. So I'm just going to use the quadratic formula here. Now, I look at this and I can tell it's factorable, but it's going to be a long factor to do it because the leading coefficient isn't 1. So I'm just going to use the quadratic formula because, quite frankly, it's probably just going to be easier. So 7 squared is 49. And then 4 times 2 times 6 is 48. 49 minus 48 is 1, and the square root of 1 is just 1. So if I subtract -7 minus 1 is -8. And then over 4, that reduces down to -2. If I have -7 plus 1, that's -6 over 4. That reduces down to -1.5 or -3 over 2. So there's actually another one in here that we just couldn't see because of the graph didn't come out very nicely in our calculator. It was just, those are so close together we didn't catch it. So I'm glad that we went and did the synthetic division to get it for real. I'm now going to draw my little chart here. So I'll just pick some test values for x, say -3, say -1.7, 0, and then 2. And I'm actually going to do this. I'm going to use my calculator here because, I guess I don't really need to. I have the factoring for this, right? So I have like x minus 1, x plus 2, and then x plus 1.5. So if I plug -3 in, I get negative, negative, and negative. 3 negatives multiplied together gives me a negative. If I plug in -1.7, I have negative, positive, negative. 2 negatives and a positive makes a positive. If I plug 0 in, I have negative, positive, positive. So that's negative. And then if I plug 2 in, I have positive, positive, positive. So that's positive. I should note here that since this was a strict greater than, each one of these zeros, when I draw them here, should have like the open circle on the number line. So if I'm just looking for the stuff that's greater than 0, I'm looking for this stuff and that stuff. So the solution I'll write, everything has a parenthesis since they're all open circles. So -2 to -1.5, and then +1 to infinity. Is that okay, Cheyenne?
Yeah.
probably more work than you were hoping.
Yeah, a little bit, it's fine.
Running into that thing you had to do the synthetic division on was kind of poopy, but we can handle it. We just probably needed to be reminded that, oh, that's what I have to do, which is not, uncommon to have to need that reminder, because you'd hope that you didn't have to go break that out again. Others, Elise. Is the review posted? Well, I guess not. We'll work on that. Others. Okie dokie. I'm good if you're good.